doesn't your results suggest that if the that you should use the exponential models instead of the neural network if you can achieve a lower error?
Yeah, that is what we are doing in order to compute numbers. Obviously, if you know what you want to represent, the best way of representing it is to represent it directly. Actually, almost. In this talk, I am not talking too much about statistical errors, approximation errors of these models, or about the generalization errors of these models. So you have some data, you don't want to actually learn the data flow, but you want that the model is actually able to cope with new data coming from the law the data was taken from. And in some way, what it is believed that if you use networks like this, as opposed to other models, like exponential families directly, that you're going to do well at that generalization. That is a big assumption. There has been a lot of success using these networks, especially these deep belief networks, and deep learning is the booming thing in machine learning. So again, that is because here I am concerned on the capacity of these models and not so much on the generalization properties. That is certainly also a very interesting subject. In fact, well, I know that, just to say a bit more, all the statistical learning theory and model selection criteria that we are most familiar with, so for models with observed variables, they do not quite work that well for this kind of model, but there is also people working on that, especially because in Japan. So there are many of them.